The catastrophic blizzards of winter, 1977 to 1978, and this analysis will shock you. What happened during those deadly months reveals terrifying patterns that could help predict when the next killer winter will strike and leave millions of people completely unprepared. Picture an entire winter that turned into a frozen apocalypse, where blizzards did not just bring snow, they brought death, economic collapse, and social chaos that lasted for months. We are talking about storms so severe they killed hundreds of people, shut down entire regions for weeks, and created conditions that modern society had never experienced and was not equipped to handle. But here is what makes the 1977 to 1978 winter so extraordinary. It was not just one bad storm. It was a relentless series of catastrophic weather events that followed a pattern meteorologists are only now beginning to understand. The same atmospheric conditions, the same jet stream behavior, and the same warning signs that scientists missed back then. The most chilling discovery came from analyzing weather data from that winter and comparing it to current atmospheric patterns. The conditions that created the 1977 to 1978 disaster are starting to align again, suggesting we could be heading toward another catastrophic winter that might be even worse than the one that killed hundreds and paralyzed entire countries. Are we watching the early warning signs of the next killer winter, or have we learned enough from the 1977 to 1978 catastrophe to survive what meteorologists fear could be an even more devastating frozen disaster? The polar jet stream controls everything about winter in North America, and understanding this atmospheric highway is the only way to comprehend what happened in 1977. Picture a narrow band of screaming winds high in the atmosphere, flowing out of the west at speeds exceeding 200 miles per hour. This is not random chaos. It forms along the boundary between mild air to the south and freezing cold air to the north, creating what scientists call the polar jet stream, a river of wind that dictates which regions freeze and which regions stay mild. The jet stream does not flow in a straight line. It forms a wave-like pattern wrapping around Earth, diving southward in some areas and lifting northward in others. These waves are called Rossby waves, and they oscillate constantly, moving back and forth, diving and lifting, relocating entire air masses with them. This oscillation is why weather patterns change from week to week. The jet stream dives south over the Midwest, bringing Arctic air for a few days, then lifts back north, allowing warmer air to return. Normal winter behavior shows a predictable pattern. A ridge forms west of the Rockies, bringing warmer air to the west coast. Then, the jet stream dives southward, creating a trough over the Midwest, funneling freezing air into America's heartland. January 9, 2007 provides a perfect example. The jet stream showed a ridge over the west coast and a trough over the Midwest, exactly as expected. This is the mean state of the atmosphere during winter. But deviations occur frequently, and some deviations become catastrophic. Blocking patterns develop when particularly strong air masses prevent the normal oscillations of the jet stream. These blocks can persist for weeks, even months, locking weather patterns in place. A blocking high over the Midwest pushes the jet stream north, causing extended heat waves. But blocking patterns can trap Arctic air as well, creating prolonged cold waves that shatter infrastructure and kill. Winter. 1976 presented something meteorologists had never adequately explained. The flow was not inverted. The pattern was not out of place. Everything was in phase, completely normal for winter, but the configuration locked into the most extreme amplification possible and refused to break. The jet stream does not lock itself into catastrophic patterns without a trigger, and what scientists discovered in the Pacific Ocean revealed the hidden mechanism driving the entire disaster. The Aleutian Low sits near the Aleutian Islands, a constant area of low pressure that creates storms impacting Alaska, while helping drive the jet stream northward on its eastern side. This flow gets further enhanced by the North Pacific High, an area of high pressure west of California that causes the ridge over the west coast. The jet stream flows around the Aleutian Low into Canada, then dives down over the Midwest. This is normal Pacific behavior. But starting in fall 1976, the Aleutian low suddenly intensified beyond any normal parameters and was literally twisting the jet stream, giving it a much greater northward component of motion. The smoking gun appeared in sea surface temperature data. Abnormally warm waters sat off the western coast of California. 1,000 miles to the west, abnormally cold sea surface temperatures dominated. Understanding the danger requires understanding three-dimensional atmospheric mechanics. Warm ocean water heats and expands the column of air above it. Cold ocean water cools and contracts the air above it. This creates a pressure gradient, and this is where most people get lost because the atmosphere is three-dimensional, not the two-dimensional weather maps we constantly see. The height of a column of air is proportional to its temperature, meaning a pocket of warmer air is inherently taller than a pocket of cold air. Air pressure decreases as you go up, which is why airplane cabins get pressurized. The pressure can be the same at two different points in the atmosphere, even though they are at wildly different heights. The pressure gradient force flows from high pressure to low pressure because atmospheric forces work to balance each other out. The anomalously warm and cold waters in the Pacific created a temperature gradient oriented in an east-west fashion, and this helped reinforce the jet stream's northerly flow over the Pacific, pushing cyclones to strike western Alaska instead of the Pacific Northwest. Alaska experienced one of its warmest winters on record. The pattern did not break. It strengthened and persisted. While the Pacific Ocean twisted the jet stream into a catastrophic configuration, what happened over the North Pole turned an already dangerous pattern into an apocalyptic one. The polar vortex acts as a containment system for the coldest air on Earth, a massive counterclockwise circulation swirling over the poles. This circulation strengthens during winter and weakens during summer, keeping Arctic air locked at high latitudes under normal conditions. But nothing about winter. 1976 qualified as normal. The polar vortex does not exist as one stable circulation. It shifts in all directions, even splitting into 2 or 3 smaller circulations that can dive southward over more populated latitudes. The precursor to these cold air outbreaks centers on sudden stratospheric warming. This is a phenomenon where air 30,000 feet above the North Pole suddenly warms tens of degrees Celsius over just a few days. The warming temperatures can slow the counterclockwise circulation of cold air, even causing it to start rotating clockwise. The situation resembles a spinning top. When the top spins very fast, it remains relatively stable and does not move laterally. But when it starts to slow down, it begins to wobble and eventually falls over. Several weeks after the polar vortex weakens, cold air spills southward, causing well below average temperatures in the mid-latitudes, similar to the wobbling top losing stability. Late December 1976 brought a sudden stratospheric warming so intense that it reversed the stratospheric polar vortex completely. Not only did the stratospheric circulation reverse direction, surface winds reversed as well. North of 60 degrees latitude, surface winds shifted from westerly flow to easterly flow, an atmospheric configuration that should not exist during winter. This allowed an area of high pressure to move directly over the poles, and this blocking high pushed the split polar vortex southward toward the equator instead of containing it at high latitudes. The atmospheric stage was now set. The jet stream was locked in extreme amplification. The polar vortex had fractured and displaced southward. Earth's most populous regions sat directly in the path of what was coming. December 1976 shattered records, but scientists watching the data realized something terrifying. This was only the beginning. December 1976 brought multiple Alberta clippers bombarding the Great Lakes region with relentless fury. Alberta clippers are fast-moving cyclones originating east of the Canadian Rockies, usually in Alberta, then flying eastward over the 49th parallel, often within 48 hours. They bring high winds and extremely cold air, but they lack the moisture that creates feet of snow. They cause brutal wind chills and extended cold spells, but they cannot dump the catastrophic snowfall that southern systems produce. December 20th brought the strongest clipper. 10 inches of snow fell in the snowbelts, and the temperature crashed from 60 degrees to 20 degrees in several hours. The average temperature for the month plummeted into the 20s, well below normal, and residents hoped January would bring relief as temperatures slowly climbed. The exact opposite happened. New Year's Eve brought another Arctic front plunging southward through the Great Lakes, and the temperature dipped back into the teens. Chicago would stay below freezing for 41 consecutive days. The first week of January 1977 was cold but bearable, with temperatures hovering around 20 degrees in Ohio. By January 6th, 95% of Lake Erie had frozen over. This is remarkable, because Lake Erie rarely achieves near-complete ice coverage in mid-February, let alone right after Christmas. The frozen lake had consequences. Lake effect snow caused directly by Lake Erie stopped immediately, because moisture was now trapped beneath the ice and could not eject into the atmosphere. However, snow accumulated on top of the ice from the near-constant flow of Alberta clippers moving through the region. This snow was very light and powdery, like powdered sugar, because the atmosphere was so cold that snowflakes were not sticking together in clumps. That meant the snow could be blown around more easily into drifts, and this detail becomes critical later. January 10th brought a pattern shift. A surface low developed over western Texas. This was not an Alberta clipper. Southern surface lows ingest massive moisture from the Gulf and can dump feet of snow as they travel northeast. Over 8 inches fell along the Ohio River Valley, with another 3 to 5 inches across northern Ohio. Conditions were blizzard-like, with wind chills near 30 below zero. As temperatures briefly recovered after January 20th, residents thought the worst had passed. They had no idea the most catastrophic event was silently forming on Lake Erie. 3-foot drifts of powdery, dry snow had accumulated into mammoth piles atop 10,000 square feet of ice just west of Buffalo, New York. January 25th brought the ridge of high pressure over the western United States, building further and further north until it sat over Graham Island, west of British Columbia. This was officially the furthest north the ridge would build all year, and the resulting vorticity, the spin in the atmosphere caused by the twisting of the jet stream, produced a constant barrage of Alberta clippers that formed and ejected southeastward toward the Great Lakes, dropping inches of snow, causing localized power outages, then sharply turning north over Quebec. The strongest Alberta clipper developed within 48 hours, plunging down over the Great Lakes and bringing a blistering Arctic front with winds of 40 miles per hour and nearly a foot of snow. The low passed over Lake Superior, causing Ohio and western New York to receive the brunt of the cold air. The temperature dropped from 20 to 0 in 2 hours as the wind blew across Lake Erie and funneled directly into the city of Buffalo. The 10,000 square feet of light, powdery snow sitting atop Lake Erie launched into western New York on January 28th, and the result was catastrophic. Buffalo National Weather Service knew this would be bad, but had not used the term blizzard in any warnings, because doing so would result in closure of the majority of businesses and schools, essentially an entire city shutdown. In the 10 a.m. hour, they decided to issue the blizzard warning. The only problem was, the Arctic front hit Buffalo just after 11 a.m. Several accounts told of a white cloud extending from the ground to the sky. That was the first wave of snow picked up off Lake Erie, carried east by the leading edge of the Arctic front. The blinding snow made it impossible to see across the street, and while many residents were still driving home after the warning was issued, they faced a choice: sit in their cars, stranded, or try to get home on foot. February brought brief relief as the ridge finally weakened and the trough lifted north. Midwest temperatures rose above freezing for the first time in 40 days. But the atmospheric pattern that caused 1977 was not finished. It was evolving into something even more dangerous. Winter 1978 started more normal, with the abnormally large ridge of high pressure returning over the west coast, then collapsing within days, bringing 40-degree weather back to the Midwest and Great Lakes. The critical difference from 1977 centered on the absence of intense blocking air masses, allowing the jet stream to fluctuate. This made southern surface lows possible, the moisture-rich systems from the Gulf that can dump feet of snow. January 15th brought a surface low developing beneath a shortwave trough over the Texas Panhandle, and it dumped a foot of snow on the Ohio River Valley on the 16th. As the trough dug southeastward, another surface low developed over the Gulf of Mexico, and the National Weather Service predicted it would move rapidly offshore, resulting in a mere 3 inches for New York City. They were catastrophically wrong. As the low crossed Norfolk, unusually intense snowfall hit West Virginia and Maryland. 13 inches fell in New York City, and 21 inches fell in Boston. The Hartford Civic Center basketball arena collapsed due to the weight of 10 days of snowfall. This nor'easter was the final straw. But here's what meteorologists were scrambling to understand. What would happen if an Alberta clipper collided with a southern surface low? Alberta clippers move fast, bring high winds and extreme cold, but they lack moisture. They cannot dump feet of snow. Southern lows pick up tons of Gulf moisture and dump feet of snow, but they lack extremely high winds and intense cold. By combining these two, you essentially get a high wind, high moisture Arctic bomb. The pressure would be much lower than a standard surface low, so all thermodynamic processes intensify. Warm moisture gets sucked in on the southern side, then rises and condenses faster, releasing energy and freezing into ice crystals. Because the pressure is lower, the colder air moves faster around the backside, crashing down to Earth, all while being propelled by a brutal Arctic front. At 5 a.m., residents across the Midwest were about to experience something unprecedented. A line of storms with thunder, lightning, and graupel, and eventually snow, was bearing down on northwest Ohio and southeastern Michigan. By 6 a.m., the Arctic front had punched through northwestern Ohio, resulting in a changeover from heavy rain to heavy, giant snowflakes, with 60 miles per hour winds and gusts up to 80 miles per hour. By 7 a.m., the temperature had plummeted from 40 degrees to near zero. For all intents and purposes, this was a cold hurricane bearing down on Ohio and Michigan. Power outages occurred early, and temperatures inside homes in northwest Ohio fell to dangerous levels. Those living in trailer parks were at serious risk for hypothermia if they had no way of getting heat. President Carter declared Ohio a disaster area, and the National Guard was sent in with gear on C-130 aircraft to help clear roads and to supply food and shelter to those in need. Many troops were from the same battalion at Fort Bragg, who had helped the city of Buffalo the year before. The storm was responsible for 51 deaths in Ohio and another 20 in Michigan. 24-hour snowfall records were set in Grand Rapids, Houghton Lake, and Dayton. February 5th brought yet another catastrophe as Arctic air surged south once again. This time, it dug further southeast, putting the area of greatest vorticity over the Atlantic Ocean, and that was bad news for New England. A surface low developed over the ocean. Because of a sharp temperature gradient between the cold land and the warmer ocean, it quickly gained speed and intensified as it followed the jet stream. Cold air aloft surged into southern Ontario and New York as the low approached the coast from the south. Moisture from the ocean condensed rapidly and produced explosive snowfall. But something was different about this particular extratropical cyclone. To the north-northeast, over Quebec, sat an area of dense air and high pressure at the surface that was obstructing the low from continuing north. This caused the low to stall off the coast of New Jersey, giving southern New England an extra 12 hours of snow. Forecasters predicted snow would move into the Boston area early on Monday the 6th. Many people woke up expecting to see snowfall and instead saw nothing. Their confidence in the weather service was shaken, and with only 6 inches being forecast, a lot of them just said, "Screw it, I am going to work." Unfortunately for them, snow started falling by early afternoon, and then the wind hit. By evening, winds in the Boston metro area were blowing at over 50 miles per hour. Thousands of drivers abandoned their cars on the interstate. 14 drivers who became trapped in their vehicles unfortunately died of carbon monoxide poisoning. On the shores of Massachusetts, Connecticut, and Rhode Island, conditions rivaled a Category 1 hurricane. 110-mile-per-hour gusts hit Scituate, Massachusetts, accompanied by 8-foot waves and a 16-foot storm surge. The blizzard occurred during a time of particularly high tides, coinciding with the new moon. This caused water to severely flood coastal areas, destroying 2,500 homes. By late evening, Boston had seen 27 inches of snow, and shockingly, Woonsocket, Rhode Island saw 38 inches in 33 hours. Both cities saw record 24-hour snowfalls. Power was out in Boston and Providence for 1 week. Fenway Park was used as a base for the National Guard to come in, clear roads, and set up shelters for 10,000 people. A week-long travel ban was instituted in Boston, something that would not be repeated until the 2013 nor'easter.